Good morning, class. The reason for this video is that today we are having English STAR testing at school, so this is a completely asynchronous day. But I'm going to walk you through today's module and the steps to complete the problems one by one. Not too difficult of a module or a concept, so let's get started. First up, you want to find today's module, which is our first gas law, Boyle's law. We'll go down here. This is April 6th, Boyle's law. You'll see the introductory video that tells you how to do it. I walk you through step by step in that video. Then there's a practice check, and then of course the independent practice that follows the practice check. Let's go into the practice check and look at an example. So if you read at the top in the instructions, it tells you exactly what to do and gives you some key figures, including the standard temperature and pressure, etc. Go to preview, and let's flip down to a question. I'm not liking that one. Some of these will be questions for the answers, and some of these will be questions about the work, just like always. This is a good one. Atmospheric pressure on the peak of Mount Everest can be as low as 0.197 atm, the standard unit for pressure. And this is why climbers need to bring oxygen tanks for the last part of the climb. If the climbers carry 10-liter tanks with an internal gas pressure of 40 atms, what will the volume of the gas be when it is released from the tanks? Okay, so let's look at our formula for Boyle's law. Boyle's law simply says P1 times V1 equals P2 times V2. What do these numbers mean? P1 is the initial pressure. P2 is a pressure after the change, whatever the change might be. V1 is the initial volume. V2, the volume after some change. In Boyle's law, temperature does not play a factor because temperature is constant. So if for some reason the temperature is changing, Boyle's law will not hold true. For our course, we don't have to worry about that. So let's look again at the question. Atmospheric pressure at the peak of Mount Everest. Obviously, you don't start at the peak when you're climbing Mount Everest. So the pressure at the peak is going to be P2. Let's go back to, we know P2, and that is 0.197. And for this particular way to solve it, you don't have to write the units until the end. And then it tells us that the climbers carry 10-liter tanks with an internal pressure of 40 atm. So that's going to be our P1 and our V1. So let's look at 40 and 10. So 40 is our pressure. 10 is our volume. I got that right. Yeah, 40 atm and 10 liters. The question asks, what will the volume be of the gas when it's released from the tanks? In other words, what will the final volume be? So what we're solving for in this question is V2. All right. So to simplify this, we have to isolate the variable, just like algebra. So 40 times 10, that gives us 400. 400 equals 0.197 times V2. To get V2 all by its own, we have to divide by 0.197. And if we divide that side, we have to divide this side. So 0.197. So now to find out the final volume, we just simply divide 400 by 0.197. So V2 is going to equal, pull out your calculator, divided by 0.197, 2030 0.457 liters. Volume is always going to be in liters when it matches the left side. Let's see how many decimal places the question gave us. 2030 is there, but it rounded it to the first decimal place, which is correct because that 5 makes this number go up. So 2030.5 if we rounded it to 1 decimal place. Liters. So select that answer and move on to the next. Boyle's law is pretty simple. That's about all it has to it. After you finish the practice check, go into the independent practice, complete that, and you'll be ready to start the next gas law when we come back next class. If you have any questions, send me a text on Remind or send me an email. I'll be glad to answer it for you. And I will talk to you next time.